You need a property sheet though, and that review sheet. One of those. Okay, welcome back. All right, here's what we're going to talk about today. We're going to go over a couple things that we discussed last few days in here. Does anyone still need that property sheet, that review sheet? Okay. This is my absolute last copy. You don't even get a note. So, you get one where it's on 2 pieces of paper. Hand it out. Oh, wait, hey, hold on. Ooh, you get a note one. I'll take that one back. Handed out more than 120 of them, and I only have 60 geometry kids. Wrap your head around that. So some people have like 3 or 4 of them. All right. So section 2.6. This is the last day of it. Just so you know that we're going to move on to geometry properties. The next section that'll be Monday. We'll be hitting a couple theorems about linear equations, about angles, and so we're going to be hitting a lot of theorems the next couple of days in here, especially next week. And I thought this was a good day to kind of like wrap this up. Today we're really going to introduce geometry proofs. How does a geometry problem fit with what we're doing? So that's kind of our goal today. So we're going to review the properties of equality one more time. That's on your property sheet that we had since Tuesday this week, or actually Wednesday. We'll do the field properties, which is the properties we've been doing the last couple days in here. Especially like distribution. We're going to talk about that today. Then we're going to do a couple examples of proofs. Couple. I don't know how many we'll get through today. My goal is to get through at least 3 problems today. Now yesterday, what we worked on is we worked on a review sheet. So if you were gone yesterday, raise your hand if you were gone. Just one. Okay. All this was, we did this review sheet in class. It was kind of an in-class activity, and we checked them at the very end of class, where it was just what was the one property that they did from the left side to the right side. They did something, like they did commutative, or they did associative, or they distributed, but you had to just name that one property. It went from left to right, and then you had to tell me if it was true or false. Okay, what I was hoping for is today that you brought that back. You brought that sheet back because I know that your partners handed it to you yesterday. I'm going to give you points for even attempting to do that yesterday because it was kind of those in-class activities, just get kind of our head wrapped around these properties. But here's the big thing that I told you yesterday. The only properties on that sheet were field properties. That was it. It was just these. It wasn't the properties of equality, because property of equality required that you do multiple lines of work to show properties of equality. The field properties just require one line, and that's what you have. Every single problem is just one single line of work. So that's kind of the idea. But again, the examples of proofs we're going to do today, we're going to talk about expression today. We're going to do at least one, where we do everything in it. Where we distribute, we do commutative, we do associative, substitution, an identity in there, because that was something we haven't seen yet. We're going to do an equation or two today, where we have to solve an equation. That's where you use the properties of equality to help. When we talk about equations, there was a simple process for how we do that, right? Where when you do equations, it's 4 lines of work for every number you need to get rid of, every digit. And that was that process we've been talking about those last couple days. So we're going to really hit that. Then our goal is to finish with the geometry proof. Okay, and that's kind of what I want to end with today. I don't know if we'll do 1 or 2 of them, just depending on what you're comfortable with. So, okay, any questions with our goals today? I have them written over here, but I just want to make sure that you saw that. Okay, so let's talk about this. Properties of equality. So these are the ones that are on your property sheet that you're looking at, that sheet that you have right here, this one. Okay, where I told you you can highlight stuff. Remember, you can't add to this. You cannot add to that, but you can just put your, you can highlight the properties. Okay, so there is reflexive, symmetric, transitive. These are the weird ones. We don't use these too often. Okay, these are the ones where they're unique. Sometimes you'll have a transitive property, sometimes you'll have to do symmetric in the very end to show that you have an exact answer. Or we might see one of those today where I show you a symmetric property today. And then we have the properties of equality, these 4. These are like the main ones. That's why I grouped them together. These are how we solve equations. We use these to solve it. That's like the first one. Add or subtract first, multiply and divide second, something like that. All right, the field properties, the ones we've been discussing since Tuesday, or actually Monday this week. Closure, which we call substitution. Commutative, associative, identities. There's 2 identities. There's the additive identity, which is adding 0, or multiplicative identity when you multiply by 1. There's the inverses. There's property of opposites when you add numbers and it makes 0, versus when you divide numbers and it makes 1. That's called reciprocal. And then the last one we've been talking about is distribution. So these are the property names. The big one on that property sheet is that for this top one, the first one, which we call closure, you're allowed to cross that word out and you can put this on there. You can put the word substitution. Okay, questions, comments, concerns on that? Okay, all right. So let's do an algebraic expression today. So I'm going to let you guys kind of work this problem out. You can work with partners, move around a little bit, get these desks moved and stuff. And I want you to attempt to see if you can simplify this problem down. So simplify the following problem. Justify each step with a property name. Okay, so here's your example. I would like you to try with some partners today. Okay, I'd like you to try to simplify this problem right here. Okay? So it's, if you can't see, it's -2 times parentheses 4x plus 5 plus 3x plus 10. So that's your problem that I would like you to attempt today. So I'm going to give you 5 minutes. Move around. You can sit with 4 people, 5 people. I don't care. Maybe you're by yourself. Let's see if you can simplify this thing down. Okay, move around. Let's try this out. Use your notes from the last couple days here. Oh, sure. Okay, there's your problem we're going to be doing.
There we go.
Okay, roughly about 3 more minutes here.
I'm sorry I hit the Facebook. Oh, let's go to the, because I got beat up. Zero. We have to.
1 more minute here. All right, hey, let's go back to our chairs. Go back to where you should have originally sat. Let's move around. Go back to where you were.
No, I'm not.
All right. Okay, we're gonna go through these. So hopefully you have something on your paper. Hopefully you. If all else fails, at least hopefully you got the math correct. Maybe not property names, but at least you did at least some work. I mean, that gives you some points in case you're like completely kind of lost or you don't know what the property names are. At least you can do some mathematics there. Because I mean, this should be a problem. You should be able to simplify them out for one. Okay, that's what I'm hoping for. Okay, now first step. Obviously, I put the 2 in here, and I put the 2 with the. In fact, it's -2. -2 with the 4x, and then -2 with the 5. What is that property called? Yeah, you have to do distribution first. It's required. You have to distribute that. That's the first step. The reason why you have to distribute, there's no way you can add these. those two. And don't like a rearrange to begin with. You have a parenthesis there. You have to do the parenthesis first. It's order of operations. Okay? All right. Now, what comes after distribution? Not substitution. Associative. We talked about every time you have distribution, the next line, we have to get rid of these parenthesis bars and put them around the numbers, which is associative. Okay? That's a big deal. You got to know the properties that follow. Especially that one. That one always comes after distribution. Right? All right. Next. Now that we have that, now we can do the property that you guys were saying. We can substitute. What's negative 2 times 4? Negative 8. Negative 2 times 5? Negative 10. So there you go. Okay, so that's substitution. Right? All right. Now, going from there, doing the actual, doing those. These are your 3 steps. Those are usually the steps for how you always distribute. The only difference that could be here, maybe I forgot to put a number in front of the x, like here. So you'd have to introduce a 1 first. That would be like the multiplicative identity, multiplied by 1. And then you could do the same 3 steps. That's kind of the idea. All right, now, what we need to do after we distribute, now, and we've done all the 3 steps correctly, now we got to rearrange. What is that called when you rearrange things? Yeah, we got to do commutative properties. So we got to move the x's next to each other, the negative 10 and 10 next to each other, so that's commutative. So now I can attempt to try to add x's together. Okay? Now here's the weird thing. This part over here is not substitution. That's like the part that's like, what? It's not? It's not, because what does negative 10 and 10 make? 0. That's a special property on your property sheet. That's why it's different than the one I did yesterday. Typically, these are just random digits, right? You add them, you just use substitution. That'd be fine. But we're not allowed to do that. That's a different property, so I'm going to wait till later. But for right now, how do I add variables? Like, what's the correct way to do it? Say it? Yeah, reverse distribution or distribution or factoring, whatever you want to call it, right? You have to pull the x's off. You can't just go, oh, that's negative 5x. You have to actually take the x off so you can put the negative 8 and 3 together. That's distribution, factoring, reverse distribution, whatever you want to call it. Okay? And now I can substitute that. I can like actually do the math there, which would be the next line, which is the negative 5, right? Okay, so that's what most people want to attempt. Now, normally, if these were just random numbers, you'd substitute here as well. So you'd substitute this math, you'd substitute this math, and that'd be it. But this is the goofy part. This one had like extra lines where negative 10 plus 10 makes 0, which is the property of opposites. They cancel. Right? That's one of your inverses. Right? It looks like substitute. You're just adding random numbers, but they're actually making 0, which is special. So that's why you got to know your property of opposites. And now the last step, when you add 0, what property is that? When you add 0 to something. It's an additive identity. Yeah. So it's additive identity. You added 0, so it actually just went away. Okay. Now, obviously, this problem's like overkill. I did way too many steps. Normally, you would never see all of these steps. You'd probably see about 6. You do the distribution always the same way. That's really the change. But usually, it's like commutative. You distribute the x out, and then you do substitution. That'd be it, like you've done. But this one went further because the 10's canceled. Okay, questions, comments on the algebraic expression? I just thought it was kind of interesting. I want to let you guys see that. All right. So, same thing now. We're going to do the exact same process, but what we're going to do is we're going to do this for an equation now. Okay, so an algebraic equation. So, we're going to try to solve for the following variable, and I want you to justify every step. So we're going to do the exact same process. So here's my example that we're going to do. We're going to do 5x plus 7 equals 27. Okay, so that's going to be my example. I'm going to give you 5 minutes with a partner, and I'm going to see if you can solve this problem out. See if you can figure out what x is equal to by giving me every step. So same thing again. You get 5 minutes, move around, sit with wherever you want, sit wherever you want, and let's see if you can simplify this problem down. And if not, at least you can watch me do it.
Yeah, this stuff's easier. Wait, it doesn't have this.
Yeah, I have to do one of those.
Sorry, don't judge me. Yeah, I've had it with the head. I almost died in PUA.
Hey, what's up with this one? Oh, I was right. Okay.
So that'll be 5 minutes.
So it's emigrated. And then we're
Did he divide what? His property is quality?
no, but I thought there would be process. First I have subtraction, inequality, then substitution, then additive. So that was right. But then okay, so I have 5x plus 7 minus 7 equals 2. That was substitution. 5x plus 7 minus 7 equals 2. Yeah. And then
Okay,
what?
about 2.5 minutes left here.
Obviously, so what's added right now? Oh, and then you're okay.
What do you do?
That's 4. Now we're just looking at 5. Okay.
It's going to be fun. I'll go for it.
That's smart.
Yeah, so division property of equality.
Take that.
Okay, less than a minute here.
Nine.
Well, you have to have that.
That was
It has to be
good.
8.
I get white face.
No, it is same percent.
But then you have to get rid of the 5, so it has to be more.
It will be the same percent.
All right, hey, let's move around. Let's go back to where you were sitting. Okay. Hopefully we're back kind of where we were. All right, so we kind of know the number of steps it's going to take. For each number we're going to get rid of here. How many steps does it take? 4. So this problem should take, in theory, 8 steps. Okay? Because it takes 4 lines to get rid of the 7, it takes 4 lines to get rid of the 5. Now the order we go in is called SADMAP, right? It's the order, it's the inverse order, so it's not PEMDAS, right? You know, parentheses, exponents, it's going reverse. Add, subtract first, multiply divided second, then you should be able to solve that thing. Okay? So, first step, what do we need to do on this problem? Subtract 7s. You're absolutely right. We're going to subtract 7s from both sides. Now, what is that called? Yeah, subtraction property called. We're actually subtracting from both sides. Okay, now, on the right side, what will that make? 20. That's what you got to make sure. It's going to make 20 on that right side. Now, What property is that where I actually subtracted those? That's the substitution. Yeah. You're just doing simple substitutions to get that 20. Now on the left side here, this is a different property. It's not substituting because these make a very specific number. What does 7 minus 7 make? 0, which is a unique property. When things cancel, what is that called? Prop of op, right? Property of opposites. They're opposites. They cancel out. Okay? So not bad. All right, let's keep going here. The next step, 5x plus 0. What do I get when I add 0? 5x, right? Well, that, I heard it, somebody was saying. Added identity, right? You're adding 0 to something. Okay, questions with the first 4 lines. I mean, they're the same 4 every single time, right? It's a property of equality. It'll be some type of sub. It'll be some type of inverse. There's 2 inverses, so it's either opposite or reciprocal. It's whatever one. And then it'll be some type of identity. That's your 4 lines every time. So now the 7's gone. Right? 7 is now officially gone in that property. Now we'll take 4 more lines. So what do I need to do on the next line? Divide both sides by 5. Right? So I'm going to divide both sides by 5. When I do that, that is called division property of equality, not subtraction. We're actually dividing both sides. Okay. On the right side, what do I get? 4, right? So that's just, I'm replacing that with 4. Well, that's sub. Just substituting. So as you can see, it's literally the first 2 properties are exactly the same. So now, what's the next type of property I'm going to probably use? Yeah, it's an inverse. One of the inverses. It's probably not property of opposites. Opposites when you add numbers to make 0. So this, if I pick one of the inverses, this one over here will make 1. That's called the reciprocal property. That's one of the inverses. And then the last step, you get rid of the 1. 1 times x is x, and what property is that? Exactly. It's got to be an identity, and it's multiplied by 1. There's your 8 steps. Most people can do the math really quick. Don't get me wrong. It's just now we got to break it down into what are the property names. Okay. Hopefully those went well. I know that first one was overkill. Like there were so many properties in that first problem, but this one is pretty basic. I mean, it's the same for every time. I really can't throw any weird things in the plan. All right. What we're gonna do for the next problem, I want to do a geometry proof. Like for the first time, actually show you how you can attempt these problems with geometry. Okay? So, back when we zoom out here, we'll be focusing on this. Alright, so this will be our first attempt at doing a geometry proof, because I do want to show you kind of how it applies, because this is something you will have to do eventually. Okay, so we're going to do a 2-column proof with the following, and I'll do it on the board so you don't have to do it by yourself. Alright, so here's the example. So they're going to give you, if this angle NPN is this angle right here, that's NPN, that's this angle, is congruent to QPN. So if that's true, this is QPN. So these 2 angles are congruent. Then X has to be 16. That's what we're going to try to go for. Make sense? Okay, so that's our setup. So this is actually a conditional statement. That's how geometry proofs work. They give you a statement. They typically give you a picture off to the right that you can kind of look at. And what we need to do is we need to prove it. So how we always start a geometry proof, just so you know. We start with the word proof. We start with proof here. First line, we always start with what they gave us. Well, what did they give me? That'll be next lines. Okay, so what they gave me is this. You just have to literally copy what they gave you. So, angle MPN is congruent to angle QPN. That's a given line. Now, I don't want you to write x is equal to 16. That's like the last line. Okay, so this is the given line. Now, line 2 is a goofy line. This is one that a lot of people don't understand why we have to write it. You have to define what congruent means. What does congruent mean in general? Yeah, equal to. That means the 2 angles, angle MPN, is equal to angle QPN. Like the actual things are equal to each other. That's the definition. That's the definition of congruent. Now, what I'm going to do here is I'm going to put the little m out front. That means the measures of those angles are actually equal to each other. That's what the little m means. So if you ever see that in your book, they're talking about the measure of the angles. So now this is a goofy line. Most people always forget that. They define what congruent means. Some people don't know what the actual word congruent is unless you define it. Now we get to the line that I think some people were saying, that when you look at the picture, the two angles are equal. So one of my angles here on line 3, this is x plus 26 is equal to 2x plus 10. And all I did here was substitute. Substitution. I'm plugging in things of equal value. Angle MPN is literally that angle. I'm substituting in. QPN is that angle. So I'm substituting that in. Now, what does that look like to you now? Say again? That's an equation. So it's going to take, a couple lines of work to do this. Okay, I'm going to go through this a little bit faster than normal because it's a geometry proof. And we'll kind of jump to the chase. We won't do all 8 lines to get rid of stuff here. We'll kind of bounce around just so you can kind of see. Because once you've shown me that you can do the algebra stuff, like the correct work, when we get to geometry proofs in later sections, later chapters, you won't have to give me all 8 lines. We can start shortcutting because you've already proven that you know what it is. So I won't require you to do it every single time. That would be tedious. We wouldn't be able to get through half the sections. So we'll shortcut a little bit. So the first line of work here, what do I need to do to both sides? How do I attempt to solve this? We're going to shortcut as we go here. So how do I need to solve for x here? Subtraction. So I'm going to need to subtract to both sides. I'm going to need to subtract a couple of things. What I'm going to do is I'm going to subtract the 1x from both sides. And I'm also going to subtract a 10 from both sides. Now, the reason why I'm allowed to do this, it's the same property. I'm subtracting the 10's from both, the 1x's from both, and that will help me solve. Now, what I'm doing there on that line is line number 4. I'm doing the subtraction property of equality. Okay, so let's substitute in the next line so we can do this. Now, typically we would put property of opposites. Things would cancel, and you'd have the additive identity where you add zeros to stuff. We're just going to jump to the chase. 1x minus 1x is gone. What's 26 minus 10? 16. Okay, and 2x minus 1x is an x. And 10 minus 10 is gone. And all I did there on this fourth line was the subtraction property. So I'm not putting in, the zeros. I'm not doing the identities. I'm not doing the property of opposites. That's what we use for algebra. For geometry, you can just jump to the chase. If you know what the property of equality is, from now on, in a geometry proof anyway, you're allowed to just write the property of equality and just do the math. Just do those couple steps in your head. Because you've proven to me, by these last couple examples, you know what you're doing. You know the process for how you're supposed to do algebra problems. So we'll start shortchanging up again. We'll start doing shortcuts. Okay, now, does this look exactly like what I needed? No. It looks a little bit different. Like, this is the goal is to prove that thing. We're just a hair off. It's so close. What do I need to do? Not cute. Symmetric. I need to flip the entire right and left side so that the answer absolutely looks identical to what I need to prove. So this is my final line 5. ... x equals 16, and that's symmetric. Now, why is symmetric and not commutative? Commutative is when you have things on one side of an equation and you just rearrange things. What I did is I completely flipped the right and left side, like everything flipped on the equation. That requires symmetry. And notice I put little ... there. That signifies that the end of the proof it's exactly what I was trying to prove. X equals 16. Now, obviously, if I was doing this with all the real steps, I skipped a bunch of steps between 3 to 4. Because obviously I have subtraction property equality, subtracting things to both sides. I would be getting zeros on the left side and the right side, so that's property of opposites. Then adding zeros, that's additive identity. And then getting that 1x out of there, that's multiplicative identity, that type of thing. because I had to, eventually there would have been a 1x here, so I had to get rid of it. But again, once we get to geometry proofs, you can start doing shortcuts again. You don't need to do 20 lines of work. Typically, geometry proofs are about 4 to 5 lines. That's it. That's all they are. They're always about 4 to 5. You always start with what you're given. Usually line 2 is always redefining what that means, because you usually have to define what congruent means. And then you're just doing some simple work, some simple algebra like this. Or something. Okay, does that make sense? Okay, now, if you wanted another one, I had another one set. It's basically the same concept. It was just, this problem was a little bit more difficult because we had variables on both sides. But I just wanted to show you this idea of symmetry, because we've never talked about that yet. I thought it was kind of nice to see that. So, questions, comments on that problem? Okay. All right, good. All right, so. And again, if you wanted another one, I had another one kind of set. I'm not going to do it because we don't have a lot of time here. But this is kind of the idea. It'd be the same setup. You know, they give you some problem, they give you some setup, and you do the same amount of work. It'd take about 4 or 5 lines again. They usually typically look about the same, so we have to do some simple algebra for that problem. I'm not going to do it, but that's what we do. All right, so here's our homework today. We do have homework today. We're going to have a worksheet 2.6. It's going to look a little bit different than what you were doing on that previous worksheet. That review guide, this thing, I'm going to want this with this sheet. So you're going to kind of like staple them together. So if you didn't have time to work on this, because I know like Trish and Trina, you guys were on, you can kind of finish this up and give some credit for it. But you definitely need your property sheet if you don't. Okay, but here's our homework today. Okay, all we're doing today is the front page. Does that make sense? Front page, the page that you put your name on. That's it. Don't do the back, do the front. We're going to save the back for a later date. Okay, remember, you're only doing the side with your name on it. That's it. Just do those 5 problems. That's all you're doing. Okay, so let me explain this worksheet you're looking at. Does everyone have one in front of them?
Yeah, we have
Extra. Okay. All right. So on the side with your name, number 1, 2, and 3. All you're doing here is you're simplifying those problems down. You have to give me every step. So you're distributing. You're doing associative. You're doing substitution. You're commuting. Whatever you need to do. Okay. The first 3 are expressions. So you have to just simplify those down. Usually it's like 3 or 4 lines. On some of those, like number 3, you'll have to go a little bit further because you eventually have to add a bunch of variables together. Same with number 2. And then 4 and 5 are equations, kind of like what we did up here. Equations take a certain number of steps. Number 4, that'll take what, 4 steps? Either the 8. 5 will take about 8 steps. Okay, don't do the back. There's way too many problems back there. We're going to save that for a later date when we do like a review for the test. We're probably looking at a test maybe at the end of next week, or possibly the following Monday, Tuesday. That's kind of what we're looking at, because we still have 2 sections to go, and all they are is just geometry stuff. So it goes really quick, these next 2 sections. So I'm expecting to do maybe a practice guide maybe next Wednesday, Thursday, or Thursday, Friday, so we can have the test the following week. So, all right, but homework is just 1 through 5. Make sense? Okay, all right, good. Okay, and this is going to be due on Wednesday for you. The reason why I made Wednesday is I know some of you take some time. Some of you have been gone, so you need a couple days to kind of like watch those videos online or get kind of acclimated into this again. So there you go.
Markla, Taylor Bob, Jackie Van Ort, and Mackenzie Harm, please come to the office. Ashley Markla, Taylor Bob, Jackie Van Ort, and Mackenzie Harm.